Today we're going to be talking about how to use function notation. So whenever you see this notation right here that says f and then parentheses with the x inside, that's how you know that you're going to be doing function notation. And you say this f of x, okay? And that means these output of the function. So you're going to have x as the input and f of x is going to be the output. And when we talk about output, what we have been using as output as our y. So if you go back to 8th grade, when you think about an input and an output table, then we substituted that to be x as input and y as output. And now we're going to be doing something similar. X is still going to be input, but our output will be f of x. Okay. Sometimes instead of being f of x, you'll see that this says g of x. It will sometimes say h of x. Sometimes it could even be like h of k or v of t. Anytime you have a letter and then one parentheses inside, it's going to be function notation. Okay. So when we use this, you can see up here the first example. If g of x equals x squared plus 3x, evaluate g of -2. You see a lot of questions like this on your STAR test. And what that means to do is every place that we see an x, we're going to substitute in a -2. Okay, so when we rewrite that, g of -2 equals, instead of x squared, we're going to put in parentheses -2 squared plus 3 times -2. Okay, and then you just solve this. If you're using a calculator, you can put everything after the equal sign in your calculator. So that would be this whole thing. Make sure that you're putting your parentheses, or you can also do it by hand. -2 squared is 4, okay, plus 3 times -2 is -6. 4 plus -6 is -2. So that would tell us that g of -2 equals -2. Okay, so down here we have a similar example. It says evaluate h of 0. So everywhere we see a k, we will put a 0. H of 0 equals 5, and then instead of a k, we're going to do parentheses 0 minus 1. Okay, so 5 times 0 is 0. 0 minus 1 is -1. So that would be h of 0. But this one says h of k equals 19. So we're not going to substitute 19 in for k, because what this is telling us is this is the output. So when we do this second part, we'll put 19 equals 5k minus 1, and it wants you to know what k equals. So we will just go ahead and solve this like a regular equation. To move that -1, we'll do a +1 + 1. 20 equals 5k, and then to solve for k, we'll need to divide both sides by 20, so we'll end up with k equals 4. Okay, if they give you the output, they're looking for the input. You can also see this as a graph. Okay, you see the function graph to the right is q of x. Use the following to evaluate. All right, so it says q of -3. So what we're going to do is we're going to go on the graph, and this means the same as what does y equal when q is -3, or excuse me, when x is -3. So if you come over here to the graph and you look at -3 and you plot the point on the graph of where x is -3, you'll see that y at that same point is +2. So q of -3 would equal +2. So if you have a problem that says, given the specific domain, identify what the range would be, then domain is going to be x values, just like we practiced in the beginning of this unit. So for -3, that would be g of -3 equals, and then every place that you see an x, instead of putting x, you'll put that -3. And then, like I said before, you can either put everything after the equal sign, into a calculator, or you can solve it by hand. Either one is completely fine. If you are solving it by hand, you want to remember to use the order of operations. So that would give you negative 3 squared would be positive 9 times 2 is 18 minus 8. So that would tell us that g of negative 3 is 10.